in projects with competitive funding, mainly funded by the European Commission. And we have been organizing these webinars since last year, where we basically focus on a specific topic of the energy sector each month. And we organize these webinars where we gather experts on this team, and we also talk about the results of the projects that we are involved. And we have been doing several webinars since now, and we already explored topics like hydrogen, battery storage, virtual power plants, offshore wind, and we already are planning to prepare very interesting webinars and topics. So I encourage you to watch also the next webinars, but also the previous ones, because if you didn't have the opportunity to watch the previous ones, you can go to our website. I will share the link in a minute in the chat, where you can watch the previous ones, and I encourage you to do that, because you can find there very interesting presentations and interesting discussions about the topics of the energy sector. And for today's session, we organized a session about buildings, about how can we improve the energy performance of buildings. And I can tell you that it will be a great session, because we have very knowledgeable experts, and I'm looking forward to this session. And as usual, we have the first part dedicated to presentations, and then the second part will be dedicated to questions and answers. So I suggest you to write your questions in the chat, or you can also raise your hand, and then you can ask the question to our experts. So don't be shy, take this opportunity to ask your questions, because it's actually really nice to have here people that are very knowledgeable and can clearly answer to our questions. So without further ado, I wish you all a great session, and I pass the screen to my colleague Claire, which will be the moderator of this session. Thank you all.
Thank you, Monica. I hope you can all hear me well, and thank you everyone for joining this session. I will just quickly go over the agenda for the next hour. So as Monica said, we will have three short presentations, followed by a question and answer session. So feel free to put your questions in the chat or raise your hand. The question can be in Portuguese or English, but we will answer in English. So I will start with an introduction to the topic, and also present some of the projects we have here in EDP New, and specifically a project called Ambience. Then Hui Fugazu from ADEN is going to talk about the legislation, current and future requirements for smart buildings, automation and control. And then Francisco Pombas from Domotica is going to talk more about the technology, the trends in building automation and control systems. So to kick off, a quick background on the topic. So I think we're all aware of the need to cut greenhouse gas emissions, but to mention here is the European Commission's target of cutting 40% of greenhouse gas emissions by 2030, and also to have a 32.5% improvement in energy efficiency. When it comes to the EU building stock, 40% of final energy use and 36% of greenhouse gas emissions of the EU is from building operations, so a really significant sector to look at. And when we see that 75% of the EU's building stock is deemed inefficient, it's clear that there is a need to improve the energy performance of not only new but existing buildings. This can be done through a variety of solutions, of course. A renovation strategy is key, and classic energy efficiency measures. However, also low cost and high impact solutions such as smart building upgrades will be key in tackling this issue. Some of the innovation challenges, let's say, that we here in our research centre are interested in exploring. We have the Smart Readiness Indicator, which I think we'll hear a bit more about from Hui in his presentation. But basically, we look to adopt the Smart Readiness Indicator in our pilots, raise awareness to highlight the value of enhanced monitoring and control in buildings. As well, always taking into account the need to improve or maintain indoor comfort, with a focus on the challenges that energy poverty bring and vulnerable clients not able to heat their homes. A common theme across our projects as well is the aggregated flexibility potential of buildings assets. So for cost savings, CO2 savings, and also on an aggregated level, providing services to the wider energy system. So that's a little background. If we to mention a few of our projects here in the smart buildings domain in EDP New, we have Smart to Be in Sato, which look at upgrading existing buildings with more monitoring and control, and demonstrating various innovative services and use cases across a range of different building types. We have Positive Project, which is more on a city level, where it aims to have whole positive energy districts, so districts that produce more local renewable energy than they consume. However, of course, a huge part of that, a major part of that, is having higher monitoring and control in our demonstration buildings. And then we have Ambience, which looks at enhancing energy performance contracts, which I will discuss a bit further in this presentation. So, some shared general objectives and challenges across all of these projects we're involved in. It's looking at increasing the smartness of assets in residential and commercial buildings. Often, this means increasing the renewable energy self consumption and ultimately reducing CO2 emissions. As I said before, there's usually a focus on the flexibility of the building's assets. How can we make the most of aggregated clusters of buildings and the demand response potential of the assets in the buildings, all the while ensuring our increasing comfort levels. Now, in all of these innovation project cases, there is a need for monitoring and control. And for these projects to become business as usual or a reality, there's the need for the legislation to implement standards in buildings. And also, there's a need for the technology. So, to be future proof, cost effective, and have a standardization and implementation. Hence, why we have some of the presentations today. So yeah, of course, we're part of EDP Group, and what's in it for EDP in these innovation projects. So the results of the projects are always to serve EDP business units with know-how for new products and services. A lot of the time, we build real-life test beds for innovative solutions to be tested, and also aim to co-develop solutions that will match the EDP's roadmap. On a wider level, it also means these projects mean we can be up to date with the European Sustainable Buildings Agenda and have a network of active players within the smart buildings domain. As well as this, we gain competencies in collaborating not only with these diverse European stakeholders, but also with the network of experts we have here in EDP. Ultimately, we want to bring innovative technology and business models to EDP's business units. As well as that, expand the smart building related capacities within our own research and development centre at EDP New, and in our pilot sites, of course, improve energy performance. So focusing on one of the projects, as I said, Ambience, it means active managed buildings with energy performance contracting. It will finish at the end of May and is a coordination and support action from the Horizon 2020 funding programme, which typically don't have big demonstrations, but in our case, we have two demonstration buildings, one in Portugal, one in Belgium. As you can see from the map, we have partners from across Europe. But here in the EDP ecosystem, we're collaborating closely with Smart Energy Lab, with also lots of support from EDP Commercial Global Solutions. So the main outcomes of the project, as I said, it's looking at developing an enhanced EPC energy performance contract template, which combines energy efficiency and demand response services. And with that, develop new or extended business models that include this active control of demand response. We're also developing tools for holistic performance modeling of buildings, as well as the calculation of performance parameters. And in this last push of the project, we really want to look at understanding the requirements for this contract to be operational by studying our two pilot buildings. So, what is an active energy performance contract? So, in a basic terms, if a classic EPC is when an ESCO invests and installs energy efficiency measures, and the savings from those measures repay the investment and also the profits shared. An active building EPC would be not only these energy efficiency measures, but it would be extending the energy performance guarantees to include this demand response within the contract for extra operational savings. So, of course, to be able to develop this kind of contract and the guarantees associated, the consortium partners have been developing various tools. We call this suite of tools the ABIPEM platform. And basically, it includes a flex model tool, which creates a baseline and reference building model, a thermal model where you need various data inputs on the building and the associated infrastructure. Then we have the energy cost cash flow estimation tool, which calculates the baseline and reference operational cost and associated CO2 emissions. Then the financial and economic calculation tool calculates overall operational cost savings, performance KPIs, investment parameters for an ESCO or other stakeholders to use to develop this type of contract. So yeah, as I said, there are two buildings where we want to demonstrate this kind of contract. We have one pilot here in Portugal, which is the EDP headquartered in Porto, and the proposed measures in that building would be some classic energy efficiency measures as well as smart control of the HVAC system. So where the building acts as a thermal battery, taking advantage of its thermal inertia and basically shifting energy consumption to different time of use tariffs to be able to create operational cost savings. In the Belgian case, it's a residential building where various renovation energy efficiency measures have been proposed, as well as that the installation of some equipment like a smart heat pump and EV charger. And alongside the savings from these energy efficiency measures, we also have smart heating and smart charging, increasing the self-consumption of the local PV, and also in this case making use of day and night tariffs to be able to make operational cost savings. So what we've seen when trying to implement these concepts is that to be able to manage, to be able to do this kind of contract, you need to measure. So even before the contract is developed, to fully understand the building and the most suitable energy efficiency or demand response measures, and also in the operational stage, so to control equipment for measurement and verification of performance. So hence why we have this session today about monitoring and control. We need the legislation and the technology to be in place for these business models and services, not only to be piloted, but to be widespread across Europe. So before I pass the word on to the special guest today, I'd like to thank everyone for listening, first of all, and anyone in the audience, especially in the Portuguese network of ESCOs or EPC providers, any interested stakeholder in this topic. We'll have a workshop on the 17th of March, and feel free to get in touch with me if you would like to join for that. But now I would like to pass the word to our first expert, Hui Fugazu. Hui graduated in civil engineering and obtained postgraduate degrees in sustainable construction as well as building acoustics. In 2010, he joined ADEN, the Portuguese energy agency, and has been involved in various major initiatives in the building sector. Currently, he's head of the projects department, and with this expertise in smart buildings and legislation, happy to have you here, Hui, to present the current and future requirements of smart buildings, automation and control. Pass the word to you.
Boa tarde, good afternoon. Thank you, Claire. It's a pleasure to be here, and thank you for EDP for inviting Aden to be here at this session and have the chance to present some of the current and future requirements. I would like also to say a word to Francisco Pombas and all the ones attending here in Portugal and outside, and I hope you enjoy this presentation. It's going to be a very quick presentation, actually focus on 4 topics: building automation and control, the legal framework, a long-term renovation strategy, the smart readiness indicator, and also the future requirements from the Energy Performance of Buildings Directive. Before going into the today's requirements, why smart buildings? Well, I believe this is not new for most of us. We know that building automation and control can really reduce thermal and electrical energy consumption, as we have seen through the specific standard 15203. And we also know through the study from the Hui study on the impacts on the region on the EPBD that there are potential to benefit from implementing building automation and control, specifically to reduce primary energy consumption by 2050 and allow to achieve the targets that were recently defined. So definitely building automation and control is here to stay. Also on the current legal framework, we now have a legislation that was updated last year, which is very well segmented into different uses and types of requirements. Specifically for non-residential buildings, we have building and automation and control well integrated. Those requirements are validated through specific projects that are designed by engineers that are comfortable and know about this topic, and basically they apply taking into consideration the type of building and also the power output of heating and cooling equipments. Basically, this applies for buildings with 100 to 290 kilowatts of power, and when we go above this threshold, we go into deeply centralized systems where we have aspects like human-machine interface, communication protocols, and consumption monitoring, data archive, and minimum energy efficiency as topics that are relevant. And for existing buildings, we will have from 2026 additional measures tackling the topics that we have seen here. On the concrete, what is expected is that after 2026, we will have to implement on buildings that have heating or cooling systems combining with ventilation and power equal or greater than 290 kilowatts, back systems that have energy efficiency class A, provide continuously monitoring, allow to do benchmarking of the building's energy efficiency, and also communicate with other technical building systems. I'm pretty sure it's going to be quite impacting. And let's see how it goes, because future requirements are going to introduce some of new changes that we will see in a couple of minutes. Going directly into long-term renovation strategies. This strategy was recently approved last year with a focus to upgrade the building stock to 2050, with the idea to improve energy efficiency and transform the building stock into nearly zero energy buildings. The focus here is to encourage deep renovations and also to focus on less efficient buildings in order to not only reduce energy poverty, but keep promoting renovation of buildings. There are 7 axes specifically. One of them is for smart buildings, with the idea to foster the intelligence of buildings to make them more efficient and safe and comfortable. And on that, there are predicted 14 measures. More or less, they address aspects like flexibility, infrastructure, or monitoring. Some examples: the implementation of the smart readiness indicators is one of the measures. Also the focus on the automation and control implementation that will happen after 2025, like I have just mentioned. Also the promotion of some installation of temperature, humidity, lighting, and CO2 sensoring. So a lot of sensoring instruments in residential buildings. And also the adoption of infrastructures for intelligent charging, also as potential examples, aside from monitoring electronic information portal and the site. These are just a few examples of the measures that are expected on the long-term renovation strategy. Going into the smart readiness indicator, this is an indicator that was presented by the Commission a few years ago, implemented in the previous EPBD. So the idea here is to raise awareness about the benefits of smart buildings, basically boosting the investments on smart building technologies and the uptake on the innovation on this sector. It's expected that this would allow to optimize energy use and production, specifically locally, optimize also storage, diagnostics, maintenance prediction, etc., and also improve comfort of users in buildings. Sorry. It's an indicator to see how ready a building is to do what? Well, to adapt to the response of the needs of the occupant, also to facilitate maintenance and operation, and also to adapt in response to the situation of the energy grid. How does it work in practice? Well, an expert will issue this SRI label, having in consideration 9 domains that you can see here on the left side. Each domain has a lot of uses and specifically functionalities. That's the number you see on the circle. And all of these domains, this catalog may impact on seven areas, the ones you see on the right side: energy, comfort, convenience, information to occupants. And at the end, we will have a label that will combine all these information. This is something that is being studied. It's one of the measures on the long-term renovation strategy, so we will see something coming out pretty soon. Going to the final part on future requirements from the EPBD, the recently proposal from the Commission from 2 months ago brought some news. For example, zero emission buildings that will have to be the standard for all new public buildings by 2027 and for all buildings from 2030, and the target for existing buildings until 2050. This means also that these zero emission buildings will have to be equipped with measuring controls, also for different uses, including indoor air quality. On the building automation and control, we will see some changes over the requirements that I have showed in the beginning. Actually, the proposal anticipates the obligation in 1 year, from January 26 to January 25, to make it mandatory for the implementation of building automation and control in big non-residential buildings, and expects to reduce this threshold from 290 to 70 kilowatts in 2030. So it's quite impacting. So let's see how it goes in the negotiations. For the residential part, from 2025, we will have to have on new and major renovated buildings continuous electronic monitoring of systems efficiency, and also control functionalities to optimize generation, distribution, storage, and energy use. On the SRI and the electromobility, we will see also some changes. The SRI scheme, which was volunteer until now, will become mandatory, meaning that for big non-residential, once again, with the power installation over 290 kilowatts, they will have to have an SRI label for all buildings that have this threshold. It's something that the Commission will produce some delegated and execution acts until 2025, so it's something that will perhaps happen in 2026. Also on the electromobility, many changes, meaning that major renovations in new buildings on non-residential buildings with more than 5 parking spaces will have to have one charging point, which will be one charging point per 2 parking spaces on offices, pre-cabling. That we had ducting as a requirement. Now we have pre-cabling, meaning that we will have the cables there in order to facilitate the installation of charging points, and also parking space for bicycles. On non-residential existing, meaning all non-residential with more than 20 parking spaces, we will have to have one charging point per 10 parking spaces, one parking space for bicycle for each parking space for cars, and also, once again, pre-cabling for 1 in 2 parking spaces for all public buildings, existing one from 2033. Electromobility also brings some use for new and major renovated residential buildings with more than 3 parking spaces. Pre-cabling on all parking spaces that will enable simultaneous use of charging points. Now we start to see how important it is to manage and control real-time charging of all parking spaces in the future, and also 2 bicycles for every dwelling, which will be a huge boost in terms of parking space for specifically bicycles. The charging points will have to be smart, and they will have to allow bidirectional charging whenever that would make sense in open protocols. Coming to an end, well, I think it's undeniable that digitalization and building automation and control will be decisive for the integration of different sectors in the EU. Portugal has started promoting this since 2013, and I think that provided a good momentum for the implementation of the current and future requirements. Let's see the impact on long-term renovation strategies and SRI, and perhaps that will boost the adoption of BACs in buildings. And at the end, I think that the future EPBD, as we have seen, let's see how the proposal and the negotiations go, will even boost an even wide spread of BACs and its relevance. And that's the end. So thank you so much for your attention.
Thank you, Hui. A really interesting presentation, really complete, and good to see the targets and requirements quite soon in the next few years that buildings will have to be smart. Sorry, I'm hearing some feedback. I don't know. Okay. Yeah. So now that's the sort of legislative and targets side. It's clear that there's a need for building automation and control solutions. So now maybe more on the technical side of how to implement these. I'm happy to introduce one of the Portuguese experts in this field, Francisco Pombas. Francisco is an electrical engineer and has been involved in the implementation of several building management systems. And since 2020 has been the sales manager of Domotica Group. I personally have learned a lot from the technical expertise of Francisco, and I'm sure we'll learn more in this presentation on building automation and control systems. So Francisco, feel free to share your presentation.
Thank you very much for the invitation. Thank you very much for your words. And thank you, Hui Fugazu, for the fantastic presentation about the new drives, the new trends of legislation in Portugal. I try to share my screen. I think, sorry for this. So we are talking about building management systems. I want to talk about three subjects. The first thing is the importance of the communication protocols, the standard protocols. The second thing is what is right now the more standard systems architecture that we are using in these systems. And at the end, why we are talking a lot about room controllers and why it's so important control at the same time HVAC, light and shading. We are talking about building automation and control systems. Normally, we look about these technical systems as we have right now in the European directives and in the European standards and in Portuguese legislation and so on. So we are talking about heating, air conditioning and so on. The old school systems that is usual for companies like Domotica have working in the last 30 years. But what we are seeing right now, it's a lot of systems, a lot of technical and IT systems that are around these old technical systems in the buildings. It's not so important about the consumption about these systems because they are low power consumptions, but they have a lot of information that we can use to drive, to manage the technical systems and have a lot of benefits in terms of energy, in terms of conduction of the systems. For all these, we are talking about the standards protocol, so it's so important. We need to communicate with different systems, and we have a multiple standard protocols right now. We called open.
Olha, eles não estão a ver, pois não, está ali a coisa da câmara fechada.
They are looking my presentation or no? Everybody is listening me?
Yes.
And,
yeah.
yes.
Okay.
Sorry for this. So this is more or less the standard protocols that right now we are using in the buildings. When we install a building management system, we need to have a lot of these protocols at the same time. We are talking about protocols connecting lighting systems, metering bus, wireless protocols like Notion and Zigbee. So when we have today, when we have a building management systems and it's mandatory by the legislation, we must use these standard protocols. So it's so important. We have a system architecture and a product, automation system that can communicate in this. This is more or less what is right now standard architecture nowadays. So it's we have a lot of we have here this automation server. It's the masterpiece of automation system, and they can communicate in the IP level in different protocols and also in field level in the Fieldbus protocols, the old Fieldbus protocols, in multiple protocols at the same time. So we are talking about a system that we have here IP level, and we have a lot of controllers connected with different protocols to this masterpiece is automation server. So right now we have this capacity to at the same time, with the same platform, communicate with different systems, with different protocols, and it's very important that we can, at the same time, use all these Fieldbus and all these IP protocols and collect all the information from different systems in different language. At the end, even the automation server have capacity to substitute the server of the system. So right now, in like said, retail, restaurants, and so on, we have a lot of sites that we don't need to have this server in the system. We only need an automation server in the site, and we can have a workstation outside the building. The positive project in Évora, the architecture is more or less this. We have in each building we have one or more automation server, but the server of the whole project is not installed in that building. It's installed outside the building in a server in the Évora municipality. So here we can it's another example for another reference brand in the market, the same automation server architecture, and you can see here in the green level we have IP protocols at the same time, and we have OPC, KNX, Modbus, BACnet, LoneTalk. All these protocols are standard protocols in IP, and here down we have also the same protocols: Lone, BACnet, Modbus, MBus, KNX. All these protocols are Fieldbus and are managed through this automation server. And you can see here in the right all the interface with this equipment through graphics and through web pages to manage all the system, as I said to you, we have in Positive in Évora. So when we talk about these new systems that we are right now integrate in our system, we are talking about some different things. We are talking about IoT, Internet of Things. We are talking about a strong and very important databases. And at this time, what's happened? It's the protocols are changing. So until let's say until the end of this decade, we are normally talk about BACnet, KNX, LoneTalk, Modbus, all these, let's say, standard protocols that we are used to work 20 years from now. But from now to the future, we are talking about IP protocols, MQTT, OCPP. It's a new protocols that normally the hardware in these building management systems are not prepared for that. So we are right now, it's necessary to convert our team, convert our technical from electrical and mechanical engineers to IT people that can manage all this information that we can receive from systems that are not the whole technical systems in the building, but it's very important to receive information from that and manage that information in our system. So in the future, we are talking about something like this. We are talking about the cloud in an IP network that all the sensors, all the systems, all the field equipment are connected through an IP network, and we have a server that manages all this information. It's more or less, in Positive in Évora, we are more or less in the middle of a standard system and this new future system. When we are talking about the standard of 15232, we are talking about something that is very important. Our system is more efficient when we can implement the demand control. So we can produce and distribute energy as we can. That is necessary for the building. So we must understand exactly what's happened room by room, space by space, to give that information to our system and generate and distribute the right energy for our building. So right now we are talking about a room controller architecture, and in the buildings, in the modern buildings, we are talking about the concept of a segment. What is a segment? It's a piece of our building, the small piece of our building that have a HVC system, like a fan coil or a VIV box, have lights and have sunlight. So it's important to understand that when we have each segment have its own controller. So when we have a big room, we can join 3, 4, 6 segments, but we also can have only one segment. So nowadays, room controllers architecture, we have something like this. We can have a segment for a small office when we have a HVC controller, a model for lights and a model for some blinds. And with this, we are talking of a small office. But when we have, imagine a meeting room, we can join 2 segments, and with that, we can have a bigger room. And it's not necessary to install more things, so we can use the same platform, the same hardware. It's only necessary to change a little the program and the algorithm of that space to join 2 segments in one only room. So of course, all these panels, all these information are available, and it's possible to use in a smartphone. So I'm sitting in my desk and control all my systems in my room. And of course, another solution for another reference brand with the same architecture, multi-protocol, and a room controller for each segment, and of course, controlled by a smartphone. So thank you for your time.
Thank you. Thanks, Francisco, for the presentation. Also super interesting. It shows the technical solutions are there, and there's different ways of going about it. Maybe now we can open the floor to questions from the audience first. I have lots of questions, but we can see if anyone wants to raise their hand and ask a question for either Hui or Francisco. If any of the audience has some questions. If not, here we have one hand.
Yes, you have one hand.
Philippe, go ahead.
Yes, hello. Can you hear me? Yeah. It's a question for Hui. I was wondering if the mandatory backs that you referred for the residential buildings will go beyond what is the smart meter from the DSO, and if it goes beyond, what equipment will be standard from 25 onwards, 2025?
Thank you, Philippe, for your question. Well, for now, what we have actually, it's a proposal from the Commission, meaning that we will still have to discuss and negotiate that with the whole member states in the EU. But looking at the 2 functionalities that we have on the proposal, we're talking about continuous electronic monitoring that measures systems, and we're talking about technical building systems, heating, cooling, etc., that monitors its efficiency and informs building owners or managers if that efficiency falls, or control functionalities in order to optimize production, generation, distribution, and energy use. So we are definitely going over the traditional typical equipment that we have, and going into a much more sophisticated approach with more equipment actually that can deal with these 2 functionalities that I mentioned.
Okay, thank you, Rui.
Thank you. But once again, let's see. At the end of this year, that's more or less when we expect it for the discussion to end, if it continues, and also evaluate what would be the impact.
Thank you, Rui. We have here also in the chat a question for Francisco. It's from Manuel Silva. He says, for legacy systems, namely using Fieldbus protocol and being accessed from outside, how do you guarantee cybersecurity?
Great questions nowadays. Look, the Fieldbus right now, it's let's say we can say that it's more security than the IP network. So right now, what the reference brands in this market are doing is put a lot of security protocols in the IP side. That is right now what's the problem. We have a lot of let's say, old systems that use HTTP protocols and without security. And right now, all the reference brands are changing that to HTTPS to be more security, and a lot of forums talking about that because, as we know, when we have an important building with all these IP protocols in a site, and we have external connection. It's important to have external connection, like as we have right now. Imagine in Evra Positive, we have all the buildings connected by IP network. It's the municipality IP network. So it's important all these communications between the buildings in the technical systems are secure, because someone from outside can not turn on and turn off the lights. It's not the most important thing, but imagine in a power plant what that can do. The field buses have the advantage that you must be in the site to connect it to that. And it's, if you have a good security team, I think it's done. So we are talking about security in IP level, and that is very important right now.
Thank you, Francisco. Maybe I'd like to ask a question in the flexibility topic, probably for both of you. But first, Hui, you mentioned that the EPBD sets requirements with the SRI level and also with an aspect of flexibility too. How does that appear in the requirements for the different types of buildings?
Now unmuted.
Yeah.
I guess we see a trend happening now, and like I mentioned, we started preparing these trends since 2013 with introduction of building automation and control. I think through legislation, the one that potentially will come out from the future EPBD, and also by incentivizing specifically the residential sectors through the long-term renovation strategy with any incentives that will promote the introduction of this flexibility, I believe we will have a boost and introduction of these systems and promoting flexibility.
Okay, yeah, good. And Francisco, with regard to that and like a systems perspective, what if we are looking at flexibility, providing services to the grid, for example, how could be the communication between the distribution network and the building automation control systems, for example?
It's a very important question, and I think it's the target for the next years. So as we can present, as I present in my PowerPoint presentation, we are talking about a lot of protocols, but it's very important to manage all these SRI targets. It's important to receive information from the grid and send information to the grid. So this communication between the building automation systems and the grid, it's very important. We are talking about the power we have available, but also about let's say prices of online prices and something like that in the future. So it's important to standardize the communication between the providers of electricity and the other commodities like gas and water, and standardize that communication in the short future. Because right now, when we have the SRI implemented in the next 2-3 years, it's important to have that target in the short future done.
Yeah, someone left a comment saying BACnet Secure Connect. So maybe that was a colleague from our distribution grid. I'm not sure, but I'm not sure if you agree with that comment. If BACnet Secure Connect is
No, BACnet per se is not the security connecting, but what's happened right now is this, the providers of the controllers developed an encryptation of BACnet. So we are talking about IP networks with security encryptation. The standard BACnet protocol is the IP protocol is not secure, but what's happened right now, they are the encryptation of that protocol in our networks.
Okay. Thank you for the answer. We have another hand up from the audience. João Cravinho, feel free to ask your question.
Hello to all, and thank you for the good presentations. The question is, many appliances in the market today are smart, but you can only see the data in proprietary software or apps. Can we converge this data in one space, or is it expected that is it expected that appliance manufacturers converge to open source systems soon?
So this is probably a good one for Francisco and the protocol expert. What do you think about that?
No, I think João have absolutely right. All the important brands in this area are developing SCADA systems and softwares and platforms in using open protocols, but with closed source software. So it's important to say that we use a platform that as you can see use multiple protocols, but the software that we use are proprietary. We have tools to send that information to a database and so on, but the standard, let's say nowadays, the standard big brands in this area are using proprietary platforms, yes.
Claire, perhaps I can also make a question to Francisco, actually picking up on this question that was made. Francisco, what's your opinion on the proliferation that we see from many small appliances coming from China and etc. that use their own proprietary software? Thinking about Smart Life, Tuya, and many others, where everything connects to those servers, sometimes in Europe, other times in China, and etc. What are the challenges for the big brands?
No, and it's important. Even some reference brands have equipment in that area. Let's say IoT equipment like smart plugs and so on, with a very cheap prices. We are talking about 10, 20 euros per devices. So this is a big challenge for big companies in this area. What I think will be the future, these companies must, and Legrand, for example, have right now different lines of product depending the application and a different level of prices. So I think in the future, some brands will have let's say domestic line of equipment with that profile and with tools to integrate that equipment in the big systems. So I think a room controller must have a price, not a high price, but a price adapt to that functionality. But a smart plug or something like that, or some line that we can put a IP motor, let's say like that, in a some line, we can integrate that in a building system. So I think the future will be in that direction. Different lines of products in the same brand and the tools to integrate that, let's say, cheaper product in the big system.
We have one more question also about communication. So communication between these equipments and smart meters. So I guess national smart meters from Edge or in other countries, other smart meters. Don't know, Hui or Francisco, if you have an idea on this question.
I think it's a good question for Francisco.
Okay, no, it's normally what's happened right now. in a building, in a big building, an office building, we have a lot of meters. So it's not one more meter or two more meters is not important. So when we need to have the general meter of a building, normally we install one for that right now. But I think that it's not the most important thing nowadays. We are talking about communication of more information about the grid. So for that, we need to develop a standard protocol, and we have right now something developed in that area that we are using in medium voltage and high voltage. So we must downsize that protocol for low tension, low voltage distribution, and this communication must be standardized in the short future.
Mm. Yeah, I mean, I guess this about the smart meter, it's maybe more relevant for residential clients, for those that are not going to add extra, or maybe will not add lots of extra energy meters to the building.
But Claire, if you are talking about the price of energy in the future, imagine your meter, average meter, send you also some information about the price or about the period of different tariffs. So all that information must be fluent and easy to receive from the meter. So it's the target will be there. The goal will be there.
So we have a question for Hui. Policy-wise, what do you think will be more critical to retrofit existing residential buildings with these technology and infrastructure-dependent capabilities? So smart monitoring and controls, I guess the balance between.
Yeah. Thank you, Tiago, for your question. Well, I think the thing that actually will be more critical is to renovate buildings, take it into account the things that really concern people more. We're talking about comfort, we're talking about providing good indoor conditions. And that's what it is in the long-term renovation strategy. That's the main focus, which is to improve comfort, to address energy poverty, and etc. It's difficult looking at the policy perspective as a whole, put building automation and control in the front line when we still have many other issues, basic issues that we need to solve. But once we continue to solve that, we will need to start bringing, because it's impossible not to do it, the introduction of smartness, building automation and control, and many other functionalities that will enable the role of buildings with the grid, with the intersection with other sectors. So we really need to bring those things. Smart Readiness Indicator, the SRI label, must be just one of the tools that will signal perhaps to the homeowner how smart that building is, what it can do, what functionalities it can have. But that's just one of the things that we will need to bring, also with examples, with policy, with incentives, with pilots, so that people see that, okay, I'm solving my basic issues, but I now have the possibility to integrate many other things concerned with smartness that will bring added value for me: consumption, comfort, well-being, and many others. Actually, like the SRI has as an output of impacts.
Sorry, Hui, thank you for your answer. Just to add, it's Tiago here. Just an emphasis on the widespread. I didn't mention that word on the question, but when we're talking about residential buildings, we're talking about individual decisions, condominiums decisions. So emphasis on the widespread. Like, how are we going to get like 1 million buildings in Portugal to be smartly managed and controlled and solar powered? Is that something like, from a, let's say, policy incentive perspective, is that even on the horizon in terms of ambition of the policies that you mentioned? And sorry, because I didn't get your whole presentation. But is it focused on widespread? Is it already inscribed sufficiently in the policy so far, or still pending?
It's not sufficiently implemented in the way you're saying. We don't have specific targets like to say having 1 million buildings connected or with this and that functionality concerning smartness. I think we will have to drive the need, the internal need from the homeowners. We're talking about residential, actually to know that there are possibilities. They feel that those possibilities attract them. They feel safe because we're talking about infrastructures. We're talking about data. Well, today with the Vodafone issue, we're talking about actually things that concern people in terms of communication, and many of these systems communicate. So we will have to bring confidence so that people trust and they start adopting. Once again, SRI, it's about adoption. I think I mentioned the word adoption in the presentation. So once we bring those confidence to the homeowners, perhaps we can bring additional ingredients like the ones I mentioned on policy, on incentives, and etc. to drive. But at the moment, there isn't any specific targets to say, let's do this on smartness, like we have on other topics, working in comfort, in reaching nearly zero energy buildings, and etc., through the long-term renovation strategy or the building renovation plans in the future.
Yeah, maybe that leads on to the question about the balance between these energy efficiency measures, so the renovation strategy, insulation, etc., and these active monitoring and control measures. Of course, there'll be some cases where maybe renovation is not possible. The smart control is perhaps a better solution to improve energy performance. But how do you think the balance between these two goals should be, Hui?
I think it's a bit like I said, that we should promote the traditional energy efficiency measures that will reduce energy demand, but mostly improve comfort and tackle energy poverty. And then once again, bring the focus on the complementary topics, where smartness is going to be one of them, aside from renewables, aside from other topics. But it's going to be more, I think, more or less like this.
Yeah, and maybe Francisco. So when you are implementing these solutions, are they widely deployed in Portugal? And if so, which kind of buildings are more advanced, and which characteristics of the building type or use pushes this advancement to be smarter, to comply with these targets?
In this business, I think Portugal or the Portuguese system integrators are more or less at the same level at the States or in the rest of Europe. So it's more or less what I'm seeing right now. And we have a lot of multinational companies in Portugal. So the office buildings right now are in the top of these new politics, but also pharmaceutical offices and plants. And hospitality, so hotels and hospitality, and hotels and hospitals are also in the new trends of all these efficiency and building management systems at the top level, as I say. So right now, the retail is not at the same level, I think, but hospitals, hotels, and office buildings nowadays are completely in the line of the new technology and the new laws of right now we adapt from Europe.
And when implementing solutions, what are the most challenging barriers you do come across for those that are not so easy to implement?
No, right now we have a problem. I think everybody knows that about the quality of the human resources in technical level. So at the medium level, the electricians, all that medium level people, we have a lot of problems right now. So I think this is not very technical, but right now it's a problem for a company like Domotica. In the field, we install the systems, and sometimes the systems don't work because the cable are not good, the right connection of the cable. It's incredible, but it's true. But we also have a lot of problems with the different profiles of the people that manage the systems. So it's important to give the right information for the right perspectives of manage the systems. And when we have a very technical people installing systems and put the systems running, normally they have a very good relationship and dialogue with technical level, but the C level, the CIO, and so on, we must offer a very, let's say, short information with a very important benchmark and so on, and KPIs, and it's important, and sometimes this is the most difficult that we have.
Yeah, maybe the SRI can be some kind of help for this. The adoption and awareness of the smart readiness of the building is easier to understand than the how many energy meters and X protocols you have in the building.
No, exactly. No, in these platforms that the different providers are developing right now, they are able to have different profiles for different users. So it's they are working on this with the information that we have, a lot of data. Construct dashboards very simple to use and very simple to analyze. It's a challenge, and I think everybody understands that's important right now.
Yep, I agree. So we're just about out of time. I'm not sure if there's any more, maybe one last question from the audience before we wrap up. If not, then I think we can try to finish on time. And I'd just like to, thank you all. Thanks, Hui and Francisco, for these presentations and the discussion. It's really interesting and important for us. And thanks to everyone for joining. I'll pass the word back to Monica just to finish up.
Thank you, Claire, and thank you all. I think it was a great session, very interesting presentations, a very dynamic Q&A. I think now everyone knows much more about how to improve the energy performance of buildings. And thank you all for being here again with us and for your support. So thank you. Have a great evening.